Here in this video, we are solving two NEET problems that appeared in 2022 in the chapter Work, Energy and Power. Let's have a look at the first question. An electric lift having a maximum load of 200 kg with passengers is moving up with a constant speed of 1.5 meter per second. The frictional force opposing the motion is 300 Newton. Let's understand what's the meaning of this is. It says there is an electric lift. It has its weight with the passengers as 200 kilograms is the mass, but the force is 2000 into G, mg, that is 20,000 Newton. The lift is moving up but not with an acceleration but with constant velocity. When the acceleration is not zero, the apparent weight is the original weight itself. But there is one thing, as it is moving up, the friction acts against the motion. As it is moving up, the friction is acting in downward direction and there is a respective frictional force, and that frictional force in the downward direction is given as 3000 Newton. So here, as the lift is moving up, both weight as well as frictional force are acting in a downward direction. Then what is the minimum power delivered by the motor to lift it upwards? See, if it has to be moved up, to move the lift up, power required is rate of change of work done by time. But work done can be done like force and displacement by time. Displacement by time can be written like velocity. So power can also be expressed as dot product of force and velocity, where that velocity is given for you as 1.5 meter per second. As the power you want to calculate is minimum, force also need to be minimum with velocity. What is the minimum force? It has to overcome its own weight as well as it has to overcome the friction. So force minimum is weight as well as friction both acting against the motion into minimum velocity, that is 1.5. That is 23,000 into 1.5. 15 3s are 45, 15 2s are 30, 30 plus 4, 30, 345, and there is 3 more zeros. So the value of that is going to be, but it is 1.5, it's not 15, so we have to put a point. So the value is 34,500. Being you are calculating the power, its unit is a watt. Like that I can solve this sixth numbered question. Let's have a look at the other question, this question. The energy that will be ideally radiated by a 100 kilowatt transmitter in 1 hour is how much? So what is given for you is power. Power is rate of change of work done. Work done can be also be expressed as energy, because that work done will be stored in the format of energy. You want energy, then the energy radiated is power into time. Power is given for is 100 kilowatt. Kilo means 1000. Into time means 1 hour, but hour is not an SI system. I have to convert that into seconds. 1 hour is 60 minutes. Each minute is 60 seconds. So that's the answer. 3 and 3, 36. 2, 10 power 2, and then 10 power 3, 10 power 5. One more 10 power 6, one more 10 power 7. So its value is 36 into 10 power 7 as you are calculating the energy, that is in joules. So for this question, this is the answer. For the first question, D is the answer. That's how we solve these simple questions that appeared in NEET 2022 in the chapter Work, Energy and Power. Thank you.